Research activities. Types and methodologies. Description of the applied research process. At the core of a software developer's work lies research activity. Unlike a code monkey, actual coding for a developer is an expression of research, conclusions, and ideas. Every line of code is inspired by meaningfulness and deep understanding of the subject area. However, sometimes a developer engages in research without writing code. When code reviews happen, we have to put in quite a bit of effort to delve into the written code, its changes, and ensure that after accepting such changes, the application will work correctly and the change won't cause a regression in code quality. Often, while doing development, you'll spend 70 or 80% of your time researching documentation and someone else's, or maybe your own code. Developing the right habits from the very beginning will help you do this without any discomfort, and on the contrary, keep your mind in good shape. The research process consists of three main components: gathering and processing information, formalizing results, and expressing conclusions. That is, first, you need to spend as much time as possible collecting all the necessary information to solve the problem. Comprehend it, and bring it to a form where, by glancing at the collected data, the conclusions and results become obvious. Research is not done for the sake of activity. Its main task is to obtain results in the form of understandable conclusions that can be checked and repeated. Before starting research, it is necessary to clearly define three levels: the field, the object, and the subject of research. The field of research defines the range of knowledge we intend to explore. For example, when learning programming, we explore the field of information technology. That is, how these technologies are generally arranged, their goals, their history, and so on. Often, information within one field has connections with each other to varying degrees. Therefore, by defining the field, we can divide the entire body of information into objects that interact with each other. The object of research is a certain part of the field on which we focus in the study. This is the target part of the research that we are going to understand and study. For example, in this course, we are studying a certain activity in information technology, software development. However, the object of research is quite a large part, which is not so easy for our brain to swallow and digest. Therefore, we take the object of research and divide it into subjects that we will directly study to understand our entire object. The subject of research, sometimes called the subject, is a certain tangible piece of information that can be formalized, visualized, and based on which conclusions about the object of research can be made. The subject of programming research is directly a particular programming language. Thus, the field, object, and subject of research relate to each other in a chain from general to specific and have an inseparable connection. Moreover, related subjects in the area cannot contradict each other in relation to the larger part. That is, if we make some conclusion by studying a specific programming language, then this conclusion should be somehow related to other languages, other areas of activity in IT, and have the same logic. This rule is due to the fact that the upper subject level of research is part of the context of the lower levels, object and field. Therefore, the more research subjects or languages we study, the better we will understand the context of development as a whole. And by studying related objects, we can make our context more confident. The whole process can be broken down into what we can call a research pyramid. Canon. This is the collection of information sources that are as close as possible to being completely true, or are actually the truth. The person who wrote the letter, code, or documentation is always the truth, since they're the primary source. Figuring out which sources are reliable is a key step because it helps us filter information accurately down the road. Setting up rules for interpreting information. This is where we get formal and lay out the field, object, and subject of our research. We also identify which sources are trustworthy and less trustworthy, and we set clear goals and tasks that will guide us in studying the object through the subject, defining terms, and doing the actual research. The results and the whole process need to be put into a form that's easy for people to read and understand. Filtering based on the context of the research field. We need to check the results we've got and compare them to the bigger picture of the field we're working in. Some conclusions might be off because they don't take the whole field into account. Filtering based on the research object's context. Just like before, this step helps filter out any wrong results that might come up because the research conditions weren't perfect. Writing down the results, making final conclusions, and putting them to use. The main mistakes people make during research are skipping steps to shorten the process. In small studies, skipping steps might only slightly mess up the results, but the bigger and more important the research, the more distorted the results will be. For example, someone might think, I know everything already, so they skip step 2 and jump straight to conclusions, then apply those conclusions without properly filtering the results. Choosing the wrong type of research because the field, object, or subject wasn't defined correctly. Sometimes, this leads to unnecessary micromanagement or, on the other hand, endless research that doesn't really go anywhere, shaping the results to match a desired outcome. This makes the whole research pretty much pointless. When developing software, you don't always need to spend a ton of time on every step of the research process because some parts will become automatic as you gain experience. But in the beginning, it's important to build the right habits by going through the steps thoughtfully. That way, later on, for smaller tasks, you can do 90% of the research in your head and explain your thoughts clearly and accurately. There are 3 different types of research, and each type is necessary at different stages of project management: exploratory or global, descriptive or detailed, and finally experimental or historical. Exploratory, global research. This type of research is used to study new objects when there is a complete lack of understanding of the task or research field. It is great for studying new programming languages, new frameworks or libraries, new areas of activity, transition from programming to infrastructure management or management, and sometimes vice versa. In exploratory research, we become acquainted with the ecosystem of the research object for the first time. So at this stage, we need to approach work without prejudices, biases, and experience in related fields, at least not to give experience a canonical role. Key stages of such research are studying canonical documentation and direct code, consulting experts for clarification, observation and monitoring. We need to make sure that canonical information comes from the authors and the code itself. When we study a library or framework, the code itself seems like a more canonical source, but as versions change, authors may modify the code to match the declared functionality. Therefore, the author is always the most canonical source of information. This means that if there is a discrepancy between the code and the documentation, we need to contact the author directly for clarification, rather than choosing a source based on preferences. When consulting experts, we don't necessarily have to ask the question directly. Forums, Stack Overflow, and mailing lists are excellent tools for finding the necessary answers from people who directly interact with the object or subject of research. When we collect information, we need to process a huge amount of data, so in exploratory research, we should structure all the collected information and check it regularly. The overall volume of materials needs to be formalized, structured, and recorded. In global research in IT, the subject should be considered in general terms to get a representation of the object more than about the subject. In some cases, there may be several research subjects, for example, several programming languages, different compilers, or interpreter implementations. The result of this kind of research is usually a document with general definitions and terms, research goals, key steps for solving the problem, a description of the subject or subjects of research, and a comparison table of features. This document will contain all the information and conclusions needed to make important production or strategic decisions. This research is often done when looking for the right tools to solve a problem. A common example is choosing a programming language to start a project. To avoid having to rewrite the project with a different tech stack later, it's important to take this research seriously from the beginning. In this kind of research, statistics and benchmarks are important, but it's necessary to look at the data carefully and think about how it fits the problem you're solving. Otherwise, you might focus on data that doesn't really matter for your task or solve smaller problems. For example, one language might handle JSON very fast, but if your project mainly uses protobuf, that won't be helpful. Descriptive, detailed research. This type of research is used when we need to get the exact details of a task. It's most often used when we already know enough about the research object to dive deeper into its specifics. It's great when we need to create a plan and timeline for a large task. For example, after choosing a programming language, we now need to figure out how to use it for our tasks, considering the tech stack. You'll probably use this type of research about 75% of the time in your work. Key stages of this research are selective examination, consulting experts, collecting statistical data. In selective research, we focus only on the parts of the object that are needed to solve the problem. We already have a good knowledge base, so we only study the parts we need to apply. For example, if in global research we reviewed all the documentation, now we focus only on the sections about fine-tuning and using specific components. When consulting experts, we look for best practices to solve the exact task we have. If exploratory research wasn't done well, unexpected problems might pop up at this stage. But if exploratory research was solid, descriptive research should go smoothly. Statistical data is often repeatable and based on clear criteria. The studied task can be laid out in a specific plan for coding certain features with a precise time estimate. Information about how parts of the language perform can be expressed in benchmarks, which should be 100% repeatable under the same conditions and give similar results. The result of this research is a document that could be called a technical specification. You could give it to a programmer, and they could turn it into code. This document has all the terms, definitions, key implementation steps, and criteria for judging whether the task is completed. But there's another type of research that's quite different in both structure and purpose. Experimental or historical research. This type of research is very different from the first two in two key ways. First, it's practical because we work with more concrete subjects. While exploratory and descriptive research focus on understanding the theory so we can apply it later, experimental research works the other way around. By working with the subject, we get a theoretical understanding of how the object works. Second, exploratory and descriptive research deal with future possibilities, what we plan to apply. But experimental research uses historical data that has already been applied and recorded. In simple terms, the first two look forward, while experimental research looks backward. These are the biggest differences between them. Historical research is used when we need to find a cause and effect relationship between what happened and what caused it. A clear example in development is tracking down a change in the version control system that led to an error in the application. This type of research doesn't exclude theory entirely, but it assumes we already have a deep understanding of the object. It would be a big mistake to jump into experimental research without doing exploratory or descriptive research first, because misunderstanding the object could lead to totally wrong conclusions. Key stages of research. Finding cause and effect relationships within the object. We carry out actions step by step and record the results. Basically, we gather statistical information and gradually change the conditions of the work. This is repetitive work that requires careful recording for each step. We're not analyzing anything at this point, just collecting data. You could call this phase historically iterative. The result will be tables showing the time, conditions, and results of each iteration. Revealing the structure, or forming a representation. Now we go through the data we collected and start looking for patterns. We group the results by common traits that we identified at the start of the research, aiming to reach the goal we set. So we don't just observe, we figure out specific patterns and causes that impact the results. The outcome of this step will be a classification of the results, typically in a table or graph that connects actions to outcomes. Understanding the fundamentals for how it works and develops. After classifying the results, we can now figure out how the object works, what impacts matter the most, and what needs to be done to reach the goal. This step essentially creates a ready-made instruction for achieving the goal. So, experimental research isn't just about guessing scientifically. It's a complete process that works with data from an already functioning object. Often, this type of research doesn't require any additional actions if the monitoring and tracing systems of the application have already collected the data. No research happens without a clear goal, otherwise it won't end successfully. So before you start, you need to ask yourself, what goal am I trying to reach? The second question is, how well do I know the subject I'm working with? Without fully understanding your level of knowledge, you might get the wrong results from the research. Research helps us organize, structure, and record knowledge so that we can apply it later in practice. Taking notes during the research builds a reference that will help both the researcher and others in the future. In fact, this course is the result of such research and is now useful. In earlier times, this process was known as craftsmanship.